And it should be recording automatically, yes. Okay, we have some people signing in. Welcome, everyone. We're going to wait a few minutes and then get started. Hello, everyone. Welcome to Ask Mayfield Anything. We're really excited that you are joining us today. I'm going to wait another couple minutes to give people some time to sign in, and then we'll get started on the topic for today. All right, it's just after the hour, so I'm going to get started. I anticipate more people signing in as we get going here. So to start things off, I'm sure you guys are all very familiar with Zoom and every other webinar platform, but just a reminder, we are going to be answering questions live during this session. So at the bottom of your screen, you should have a little menu bar. There's two different options. There's the chat function and then there's the Q&A. So for your questions, make sure you're using the Q&A box. It's a lot easier for us to keep track of questions, know which ones we answered if they're in that Q&A section. The chat function, we're mainly going to be using that to share some links with you. So throughout this discussion, there's a couple resources and blog articles that we want to share with you that are good resources. So we'll be putting those links into the chat feature. So keep an eye on that. And that is pretty self-explanatory. If you have any questions on how to use that, submit them. If you have questions throughout this discussion, put them in the Q&A and we will get to them. So this is Ask Mayfield Anything. And if you've attended previous ones or if this is your first one, welcome. Thanks for joining us. This is a monthly series that we're doing, and we've been picking a different topic each month and then talking a little bit about that particular topic and answering your questions, either ones that you submit ahead of time or ones that you submit in advance. And today, let's see if I can click through these slides. So my name is Jennifer Alfson, and I am the Director of Business Development for Mayfield Renewables. I've been in the industry for, let's see, almost 10 years now. And my background's as a mechanical engineer, and I have had the honor of working with Ryan Mayfield for the last almost 4 years now. And Ryan is our leader and CEO. He has been working in the renewable energy field since 1999, and he founded Mayfield Renewables back in 2007, initially as a design services firm. We do additional things now, which we're actually going to share with you a little bit later. His career has blended technical expertise with an affinity for writing and education. And while serving as our CEO, he was also the PV Systems technical editor for Solar Pro magazine from 2010 to 2018. And he regularly wrote feature articles and contributed to Home Power magazine as well. He's also the author of PV Design and Installation for Dummies, which was published back in 2010. And he teaches nationwide PV courses on topics such as the National Electrical Code, Oregon Solar Code, and PV systems, commercial PV systems, PV and storage, anything you want to know about PV. Ryan's your guy. He also holds a limited renewable energy technician license in Oregon and is a Oregon Solar Energy Industries Association board member. Hi, Ryan.
Hey, thanks. And I need to add this to my bio, I guess. And I was admitting this to the group before everybody joined in. I'm now semi-obsessed with Hamilton. So if anybody also wants to talk about Hamilton the musical or any of the songs, I would love to do it because I'm getting a little more than semi-obsessed at this point in my life.
And I still need to watch it. So maybe that should be my homework before the next AMA, watch Hamilton. So thanks for doing this.
Thanks for everybody for joining. This is going to be great. I'm really excited.
Yeah. And our topic today is going to be on solar plus energy storage and how that relates to the NEC, primarily NEC 2020. I think we will be touching a little bit on 2017. And to dive into that very hefty topic, our special guest today is Justine Sanchez. She is our senior technical and design analyst. Justine is a total badass and has been in the industry for the past 26 years. She brings a wealth of experience in technical writing, PV education, and industry leadership to the Mayfield team. Her career in solar PV has taken her from being a hands-on technician at the National Renewable Energy Lab to develop educational curriculum and teaching hundreds of courses at SEI, and now acting as a senior PV technical editor for Home Power magazine back when that was still in print. As the senior analyst with Mayfield, she wears many hats and specializes in PV system plan set review, system consulting for Solar+Storage, and now has actually been developing an education series, a series of workshops specifically focused on energy storage. So welcome, Justine, and thanks for joining us this morning.
Thank you. I'm excited to be here, especially talking about storage, my favorite topic.
Yeah. So speaking of storage, we are going to dive into this topic pretty in depth, but I did want to start off with us just mentioning, let me scroll over to that. This is a pretty massive topic and there's so much to cover, and that actually is what prompted us to start putting out content on that. We're going to talk a little bit about the blog post and get into that, but we did want to give you a sneak peek of what Justine has been working on. So I have up on the screen right now some of the workshops that are going to be coming up in 2021. Justine, if you want to speak to those, and what does that entail? What are these workshops? How's that going to work?
Yeah, no problem. So we have just realized with the influx of all this new technology and new codes and new fire code, there's just a lot of questions surrounding the topic of Solar+Storage, and with our own projects, we just see how these come up in the real world. And so we want to kind of deal with this issue head on and offer a workshop series spanning all the topics that we've been coming up against. And so essentially, we're offering 2 workshops per quarter for your company. You sign up, we help you schedule a time that works for you and your staff. And basically each workshop would be a 60-minute presentation followed by 30 minutes of Q&A. And then it is NAPSEP certified, so we can get credit for that. And then we'll have rotating topics throughout the year. So in Q1, our first topic will be covering actually a lot of, we're just going to be hinting at here, the NEC 2020 and NFPA 855 fire codes for ESS. And then in the second quarter, we'll be hitting heavy the available products for both commercial and residential projects. And in the third quarter, we want to dive deep into the design considerations, like looking at AC versus DC coupling, or how you actually size an energy storage system, depending on what you're trying to do with it. And then fourth quarter, we want to dive into implementing the NEC in your design and getting into the nitty gritty of wire and overcurrent protection device sizing for your different circuits, disconnects, interconnection options, labeling, and so on how all these things that we're going to talk about today actually play out in a system and how you work through those requirements in your designs.
Excellent. So
yeah.
Really in-depth workshops, and it sounds like covering a whole host of topics specifically to energy storage and really code compliance, and how does this all work and how are you going to implement it? So with that, let me scroll back to one of our previous slides and let's dive into this topic. So you recently wrote a blog post on Solar+Storage design considerations. Oh, and by the way, our Lucas just put the link to our energy storage workshops in the chat. So if you're wanting to look at that again, the link is in the chat box right now. And then this blog post that is up on our website, it starts to dive into this topic of Solar+Storage and what are some of the design considerations. So maybe Justine, you can dive into that specific.
Sure. Yeah, this blog was created basically to help designers get a handle on where they need to go in the 2020 NEC to find the various requirements for their particular system. And so you'll find as you get into these systems, like, where do I go? Am I going to go to 690? Am I going to go to 705? Am I going to 706? What are these new sections and what's covered in each one? And how do I know where to apply or which code sections to apply to my system? And, where do they overlap? Or, where do I have to really go to a specific piece of information? And so we really tried to break that down in the blog post, and actually we created a graphic to give you a starting point, essentially, which we'll talk about later in this topic. But Ryan's going to go over a little bit on the codes that we do cover in the NEC that touch on storage.
Yeah, so as mentioned, they're all over the place. And so we have a nice graphic coming up to kind of help show that. And Justine talked about it in the blog, but, talking there, and they're not even all depicted here. So in NEC, in the National Electrical Code, there's somewhat the obvious for PV. There's Article 690, 710, 705, maybe 710 is not obvious, but 705 being big ones that we're in all the time. And other ones you have to think about it and consider 480 for storage batteries that may or sometimes may not come into play when we talk about ESS. We'll get into that a little bit more here in a bit. 706 was new 2017, so that's our ESS article that definitely need to pay attention to. 705 if the utility is present, 710 for standalone systems. So it just becomes this big conglomeration of all the code sections. And I think we'll talk about this a little more in depth later, but things that you have to be aware of or be thinking of are, emergency systems, standby systems, microgrids. So there's different, there's Article 700 for emergency systems, 702 for standby, 712 for DC microgrids. So there's just a ton of back and forth you may end up seeing. And then, for example, when you're in 706, looking up some of the references, they'll send you to 705, they'll send you to 712. And so that's just something that, we have to be aware of. It's not really new for us in the PV industry having to jump around in the code, but it seems like with this topic, it seems even broader in my mind.
Yeah. Go ahead. Do you have a question?
Yeah, well, so I'm seeing 690, most people know of, people have heard of 710. I guess the new one that just came out was 855. How does that overlay onto this diagram?
Yeah, it doesn't, in the sense that this we're specifically talking about the NEC, National Electric Code, and NFPA855, whereas the 855, which we'll get into next in this discussion, is specific to fire code, and it's a whole other set of requirements you're going to be looking at. So you've got your NEC, and then you've got your fire codes, and they may overlap. They will overlap, but they're two different topics, really. So we'll jump into just the NEC right now, the electrical code, and look at how, what are the certain sections that we need to pay attention to, because, well, actually, you go back. That's where I was at, was that diagram. So we, as you start to pick apart these systems, this is one example that we played out for you here, because this is the most common type of energy storage system that you're probably going to see, an AC coupled energy storage system, because what's going to happen, or what's happening, is that people want to add storage later. So they may have a PV system already installed at their house, and they've realized, wow, I don't like these outages. I want to have some backup power in case the power goes out because of these various reasons that it's going out. And so this is becoming, I would say, probably the most common system architecture is an AC coupled system, where you have an existing PV system with your interactive inverter, and then you want to come in and add storage later. And so to do that, you need to utilize a whole separate multi-mode inverter that's going to work in conjunction with your interactive inverter. And so the systems get very complicated very quickly when you add storage, especially after the fact. If you can design it that way from the get-go, that's great. You can probably save some money, boost some efficiency. But the reality is we're seeing a lot more AC coupled energy storage systems these days. And that's why we really decided to make this diagram the focus of that blog, to show how these code sections overlap. So we'll just start with like NEC 690. So it's interesting because people that have been in the industry for a while might remember that there used to be a section on energy storage, on battery storage, actually, in the NEC 690 section. That was removed in 2017 with the new edition of Article 706. So those of you that have been in the industry for a while, you're like, wait a minute, I'm going to add a battery system. I used to see some stuff in 690 about battery storage, and you go there and you realize it's gone. It's really, there's hardly anything there on battery storage anymore. And so you might think like, oh, great, I've dealt with my PV system. I don't even need to look at that anymore when I add my energy storage. And that's actually not true. There's some things you need to think about with your energy storage system, with the addition of an energy storage system like rapid shutdown. And that's the thing I kind of focus on in the blog section on this Article 690, because with a rapid shutdown system, a lot of folks that have maybe put their system in a while ago, their rapid shutdown might be their interactive or their interconnect, right at their interconnect. And so if the grid goes down, it just automatically shuts down the modules. And so in this case, that's not going to happen, because we're adding these energy storage systems so that we can have power when the grid goes down. So when we put these systems together, that energy storage multi-mode inverter can keep the interactive inverter operating during an outage situation. We want that. We want access to that solar power when the grid is down. But what we don't want is for the the fire chief to come in and hit the rapid shutdown and still have an active PV array on the roof. And so we have to think about where that PV, the rapid shutdown device lives, and that it actually shuts down the PV power when you hit the rapid shutdown device, instead of just thinking it's shut it down and it's really still alive. So that's one thing that you'll have to really think about as you start designing these systems. Where's my rapid shutdown, and does it do the job that it needs to do when you hit the rapid shutdown switch? And the other, let's see, I have some notes I'm going through here. The other thing to realize is so those requirements that used to be in 690 didn't go away, they just got moved. And so now you may be going to Article 480, which isn't even on here, because a lot of our new energy storage systems are really about lithium ion storage, and which 706 is more aligned with, whereas 480 is really more specific to lead acid battery banks. And so you're going to be going to, in this particular case, let's assume this is a lithium ion battery bank, you're going to go to Article 706 and look for specific requirements. Now that's where you're going for your disconnecting means and installation requirements, like your working space and your directory. It talks about your DC voltage limit, your circuit sizing for multi-mode inverter input and output circuits, and your charge control requirements. And so you need to know, like, oh, Article 706, that's where I'm going to find those requirements. But then there's a couple of other things your system's also doing. It's also interconnected to the utility in this case. If that's the case for your system, which is going to be for the majority of, I guess, for all backup systems, I should say. And so 705 is still where we're going to go for those interconnection rules, and where we have to look up basically, are we going to do a load side interconnection or a supply side interconnection? And what are the rules that govern those types of connections? Identification of power sources and all those things that go when you interconnect with another power source, in this case, the utility grid. But then you're not done, because we are also looking at Article 710, because when we operate in what's called island mode, we're operating as we're like a standalone power plant, and we have specific requirements for basically these standalone systems. And so I'm actually, what is 710 called? Is it standalone systems? I don't have it up in front of me.
I can pull it.
Oh, that, yep. It's, well, actually, do I even have that here? I should know the titles of these.
It is. You got it.
Okay. Great.
Yeah, standalone systems.
Good. And then we have to look at that code section, and that's where we're going to find our requirements for, okay, if when we're in island mode and because the power is out and we're just supplying these, you know, critical load, or I shouldn't use the word critical, these backed up loads, what are the requirements there? And there are some requirements. You might be surprised to know that like your inverter capacity has to be sized at least large enough to handle the single largest load in that backup panel. It doesn't have to be large enough to handle all of them all at once, but at least the largest single one. And so you actually have to think about, what's in my backup panel? How big is my multi-mode inverter? And then there's other details on voltage and frequency for the connected loads. It has to be, you know, workable for the loads that are in that backup load panel. And there's some other requirements too for very specific to, you know, not allowing your backfed breaker, if that's how you're feeding the power, to fly off when the system's energized. You have to secure those. It's kind of these old tiny requirements that used to live in 690 have been kind of split out now into 706 and 710. And we just have to know as designers now where to go for that information. It's not that it necessarily, that those requirements went away. It's that they got moved and altered to deal with kind of the newer types of systems that are evolving.
Mm-hmm. So I wanted to, I guess, comment and question on a couple things you just said. So one, that I noticed that you corrected yourself on a term that I'm not sure everyone caught just now, which is the distinction between saying a critical load panel or critical loads versus backup loads. Can you explain why there is a change in the language when people talk about critical loads versus backup loads?
Yeah, because you can get into other terminology in the NEC specific to critical loads. I don't know if I have the NEC reference. I don't know if Brian, you do?
Well, 700's emergency systems.
There may be actual another section specific to where you call critical power, and then you might be talking about like hospitals, and they have very specific power requirements. And if we start calling our loads critical loads, they may, you know, and an AHJ might interpret that to mean that we have to follow even more stringent requirements, when really what we have are backed up loads. And so we just need to be a little bit careful. I got called out on this as a writer for Home Power Magazine. I'd have John Wiles and others telling me, don't call those critical loads, you're going to get us in trouble, and have us, you know, then all of a sudden the HJ's telling us we have to comply with this whole other code section that we don't, because that's not our situation. That's why I corrected myself.
Yeah, no, it's a good, I like pointing out those little things, because as we learn them, it's really easy to forget that we did it one way and then now we're shifting. And so I think it's good to help educate everyone in the industry of like why that shift happened. Just a side note, we are getting a few questions about whether or not this is being recorded. So I did want to let everyone on the line know that yes, we are recording this right now, and we will be sending it out to you in a follow-up email, and then we'll also be posting it on our YouTube channel. And if you want to look at other past AMA sessions, they're all up on our YouTube channel. So great, Justine, thanks for that breakdown of the codes. And I know you have more to touch on. One more question I had in terms of the backup loads panel, and this is just in terms of, the technology is changing and advancing so rapidly, and codes are struggling to keep up, mainly because of just the code cycles and the way that they work. And there's always going to be a 3 to 6 year lag between when stuff gets technology advances and when a code actually gets implemented. I'm curious, how do you see these new quote smart panels fitting into this, of being able to design smart panels where you're replacing the entire main service panel with a quote smart panel, so you don't have a separate backup loads panel? Does that complicate things? Does it make it easier from a design perspective? What are your thoughts on that?
I'm sure ultimately it'll make it a lot easier, just to have control basically over those loads, and not worry about bottoming out your batteries, because your house is, just set up to automatically turn on the AC or turn on, everything all at once during an outage situation. So it will definitely have its advantages, but there will be a lag time in trying to figure out what code sections are we going to now have to go to for the specifications for that panel. And honestly, I don't know. I mean, the Article 710 will still apply. We'll still have to, comply with what's going to be operated in an island mode situation. And hopefully, that code language is written generically enough that we won't run into problems there. That's a good question. I don't know, Brian, if you have any input here on that.
Yeah, I'm not sure specific to that, but I think ultimately, in terms of doing a whole house backup, which I know is when we're talking residential, people get really excited about having a backup system, and then tell them you're only going to be able to do certain loads. It seems like, what are you talking about? I want to be able to run all these things.
Yeah, they're like, what? I can't stream Netflix from my spa?
Exactly. My wine cooler is going to get warm. So a lot of part of that is from education, obviously. And I know, our friend Greg Smith will scream up and down about that. I know he has a lot of to say about that. But nonetheless, I think it will ultimately help us, just in the sense that, just in what Justine was saying, is, the power goes out, you can program it such that without the utility present, the breaker for the AC unit is just going to sit in the open position, and it just isn't going to come on, and you can do other loads. So it's going to be easier to give people more of a whole home backup type situation. So I see it as a big positive.
Excellent. Yeah, I'm curious to see how that starts to get integrated into systems, and how the code adapts to start incorporating those things. So this is kind of a good, and I know there's more to chat or discuss about 855. Before we get into that, I did want to ask one of the first questions that we got in ahead of time, because it relates to what you were just speaking to. And this question came in from Matt Serum, and he was asking, what defines a quote ESS system? So what energy storage options are not an ESS? So I think looking at this diagram, I think the question is more, what components are you supposed to include as part of an ESS system versus just the PV system? And then in that, when does Article 480 apply?
Yeah, so with that, so there's actually some changes 2017 to 2020, and with 706 being a new article in 2017, I think as folks that have been around code long enough has seen, when the new articles come in, or even new sections for that matter, come into play, they're not always the greatest. And so one of the things, as far as a definition for ESS in 706, sorry, I scrolled away from it, or flipped away from it. There is a definition in the very beginning of this section of Article 706 on what it is. So that you go read that, that definition. And then the other part of it that kind of plays well, or kind of plays right into it, is getting into 706.5, which talks about the equipment itself. And there's a change there from 2017 to 2020 for folks to be aware of. And so in 2017, it talks about basically all of these components that you can take put together as individual listed components and create this ESS, this energy storage system. And it actually calls out batteries as part of that, and specifically calls out lead acid batteries as not being required to be listed. So lead acid batteries in general, and that's shows up in 480 as well, are not required to be UL listed. And so there was this ability to take individual listed components, build up a system that would be considered an ESS, energy storage system, through listed components. 2017, Justine, correct me if I'm wrong, but that changed a little bit in the sense that the language it just got stricter. The definition really didn't change. So the definition is all the components required to, and I'm paraphrasing here somewhat, so I don't read code language to you, but all of the components required to store energy and then deliver it within your distribution network at a later time. And in 2020, the definition also, or not the definition, excuse me, the equipment requirement later in 706.5 says it needs to be listed. And so now we have all the equipment needs to be listed. It's not saying take individual components. And so we have a listing 9540. There's a couple others I'm not going to remember off the top of my head, but in 706.1, they do list out in one of the informational notes all the different UL listings that apply. So there's that aspect of it. So, I mean, it's a long answer for a short question on what is an ESS. And the problem is it's not a super straightforward answer.
Yeah. So when you say it has to be NEC 2020 is changing it to they all have to be listed, you're talking about, I mean, there's a difference between component listing and system listing. So are you talking about listing each energy system UL listed as a system, or each component UL listed, and then you're able to mix and match your components together?
So the language, the language says energy storage systems shall be listed. So it's just saying as an energy storage system that the whole unit itself has to be listed, not individual components.
Mm-hmm. Yeah, so how does that work with, I mean, isn't that going to be just a total nightmare?
Justine's been digging into this a lot, and we were actually having a big conversation about this right before the call.
Yeah, I mean, it's trickier, definitely. If you're going into 2020 code and all of a sudden you have this requirement that is very vague, it must be listed, and then it's changed from it used to be able to be listed of these different components to being listed all together. I think the bottom line is they want to make sure this stuff all works safely together. And it seems like the only safe way to do that is to test it all as one unit and list it all as one unit. And so because they are concerned about these little, powered storage systems going into everybody's homes and not being fully tested in these different situations. So really, ultimately, they're worried about fire. And that's the whole point of all these codes, is reducing the potential for fire or shock. And so it's getting harder. It's getting stricter, I would say. And that leads me right into actually 855, if we want to jump right into that, because that is where we're at. The NFPA 855 is a new standard that was just released last September, not September of 2019. So it's been around actually for a year, but it's not going to be starting to be implemented until just, as different HJs start adopting various fire codes, either the 2021 NFPA1 or the IFC 2021, then you're going to start to see this new language that has come about in 855. And so really, this is the standard, basically, that provides the minimum requirements for mitigating the hazards associated with an ESS. There's been some high profile fires for larger systems that have really led to the industry feeling like we need a standard like this. These are going in at a rapid pace, and we need some guidance here on how to safely implement these systems across the country in various settings. And so they have different parts of the book are essentially geared towards either residential or commercial. And here's a taste of some of the things that are included. This is for non-residential, you're going to see things like construction documents, specifications for construction documents, emergency planning and training, hazard mitigation analysis, a large-scale fire test by a national recognized testing laboratory, They start getting into spacing. They want to see 3 feet between units. Now, what's a unit? Well, that's defined a little bit late. It's another part of the code, or the standard, I should say. Like for an indoor installation, they have a max energy rating per unit at 50 kilowatt hours for lithium, and a max per location. They have charts that will tell you if you're at this type of location, this is the max per unit, and then and each unit will have to be then separated by 3 feet. And basically they want, if a fire starts in one, they don't want it to propagate to the other units. And that's what that spacing is about. There's specifications for fire control and suppression, like sprinkler systems. And then battery location types and requirements, depending on if this stuff is going outside, is it going inside, then your requirements differ versus rooftops. And then a maximum, and that on that max rating per unit, that was for an indoor location. I don't know if I said that. And then maximum stored energy overall, like there's an example, say 600 kilowatt hours for lithium ion in specific areas. So there's all kinds of charts and tables in this book. It's actually a really, really educational document. I mean, even if you don't have to comply with the requirements that are in this standard, it's full of really fascinating information if you're a total storage nerd like I am. They even have annexes for basically how to deal with the different hazards that exist for if you're dealing with lead acid versus lithium ion. And then they actually have a section specific to firefighters and as a resource to them. And so they're really trying to take this issue head on how to install these energy storage systems, because we do want them. They're providing a really valuable service for our energy industry, but how do we do it safely? And so that's what the NFPA 855 is about. I don't know if I mentioned chapter 15 is specific to residential applications and it has its own set of lists, which are really also interesting. And so if basically these are the new rules of installation for storage coming down the pike, depending on when your region, your HJ adopts either the International Fire Code 2121 or the NFPA 2021.
Excellent. Yeah, so a lot of information. Whoops, I went away from that. Can you still see my screen?
Yeah.
Okay. Lots of info in there. And just to note for everyone on the line right now, I'm going to put a link to the UL website to, oh wait, sorry, that one was 9540. I was going to say, if you're interested in digging into some of these, I know for UL, you can view the digital version for free. Does the NFPA have something similar? And I just noticed that's typoed on the screen right there. NFPA.
I'm not so sure. We bought the standard. I would say your I codes. I mean, a good place to start if you're is look at your existing your fire code for your area. You're going to say a lot of the same language, because it's not that this installation requirements are entirely new. It's just that they've gotten more stringent. So going to your I codes, those you certainly can view online for free. And then finding in your particular area where your fire code talks about energy storage, and then looking at those existing rules, and then it's not a bad investment to get ahead of the curve and get yourself a copy of 855. It's a good question whether it's available somewhere for free. I don't know that.
Yeah, I don't believe it is, but I could totally be wrong. And I know with like the UL standard, somebody asked, the UL standard, the 9540, you mentioned that, Jennifer. So that is the go-to standard that UL writes, but that's going to, for the average installer or whatever, is not going to necessarily need to worry so much
dive
about
into that. Yeah, that's more for the equipment
the
manufacturers.
But yeah, it's definitely worth a look. And as Justine mentioned, even if it's the 855s, it's not a super expensive document, and definitely worth taking a look at. Especially California. Is it July, Justine, or June?
That's what the word is on the street. July of next year. This will be the language that will be included in the fire code.
Okay, so it's going to be part of the fire code. So it's not necessarily that NFPA 855, the standard is going to be the enforcing document, but it's going to be the fire code that incorporates 855.
I believe.
So, meaning the International Fire Code by FC is
Yes.
reference 855?
The IFC, yeah.
Okay. So that was going to be one of my other questions, because I notice on here, this is called a standard and not a code. So is that to mean, right, as of right now, is this actually being enforced or adopted anywhere?
Once the code's adopted, then it will be enforced. This is the standard that they go to for their language, for the information on how to comply. But the actual, law is the code. Correct me if I'm wrong, Ryan, but that's my understanding.
Yeah, correct. And so, for example, here in Oregon, we have our Oregon specialty structural code, Oregon specialty code, and it does pull language, but that's the code that we go to, but they go and pull some of this language from these standards, 855 being one of them. So it is interesting how they do interplay with each other, but yeah, this is not necessarily a code that your inspector is going to pull out and say, you didn't meet the 855 standards. It's going to be, because that's not a code.
Yeah. And so I guess that was actually the second question to ask you. I just naturally asked it anyway. Are there any other, I guess, comments in terms of when you were saying July 2021 is when you anticipate this starting to get incorporated into different AHJs? Are there AHJs that are starting to adopt this ahead of that?
I don't believe so, and
Not.
it's also getting incorporated in NFPA1, right? Is Justine, didn't you?
Correct.
So NFPA1 is in some jurisdictions, and so it's a fire code that some states adopt, and so it's, as far as I know, it's not in that. I think it's coming up in the next revision, though.
Okay. And then, so moving on to some of our later, or do you have any other comments that you wanted to make on 855? I'm going to move on to the next question.
Yeah, we're good.
Okay, so this one came in from our friend Greg Smith, and he's asking, is it well established, or it is well established, that LFP is a safer chemistry than NMC? Will the code ever make exceptions to storage system installation location or any other considerations based on battery chemistry? So lithium ion, what is it? Lithium phosphate. Let's look.
Lithium iron phosphate. Yeah, it's the first question I had too, Greg. I'm sorry to say I can't really answer that with a straight answer. But when I opened this document and I started looking at the charts and I realized, wait a minute, they're lumping all lithium ion together as if it reacts the same in these different systems. And if you've looked around at some of the different technologies that are out there and certainly read their promotional material, it is the common, I guess I'll buy it too. I believe this as well. Lithium iron phosphate is a more stable chemistry. This is my personal opinion, I guess, based on a lot of reading and research on the topic over the last 5 years. Then some of its other lithium, like NMC, for instance, there's been some high profile fires involved in a NMC type lithium. So when you go through these documents, you're like, well, wait a minute, how come they're not differentiating LFP as opposed to NMC on how they would react, or what are requirements for installation? It should be easier, right? Because this is a more stable chemistry, or it doesn't, what's the word? Thermal runaway is less of an issue according to the battery literature that is out there with LFP versus NMC. So, but it doesn't distinguish. And so, Greg, that's a question right back at you. I mean, it would be nice for installers and designers to be able to fall back on that type of information in the code, but it's not certainly in there yet. And I'm not sure when we can depend on it to be there, although I can just say, educate your installers and your HJ on the different technologies, and hopefully you can work it out with them.
Yeah, and the only thing I would add is, for those in the have seen code making happen. I mean, right now, code making for 2023, I believe we're past due. I mean, you can't even make comments on 2023 NEC at this point. I mean, they've already submitted first draft of comments and things like that. So code making is a years long process. And so it's very hard for code to keep up with the technology changing as quickly as it can. And so while there probably is some merit behind having different technologies, having different code requirements, I think it's just really hard for the code bodies to keep up with that and be able to effectively make those, not exceptions, but make those cases. So, yeah, it would be great, but probably not going to happen. But it's definitely something that if you can talk with your AHJ through, it seems, it's worth having the discussion.
Mm-hmm. All right, so looking at some of the other questions that we got submitted in ahead of time. So are there any voltage limitations for energy storage systems?
Yeah, and so with that, I think the question's probably regarding the DC battery voltage is probably the root of that question. And in 706, 2017, I'll start there, start in the early years. 2017, 706, I believe it's 706.30, talks about the voltage limitations, and essentially is the 100 volts. And this is specific to residential. Is that correct? Justine?
I believe so.
Dwelling units shall not exceed 100 volts.
I was gonna say, I know that for a fact. I memorized that one in 2020, but not 2017. But there is an exception. So it's 100 volts, and there is an exception of if the terminals are not accessible during routine maintenance, that you can go up to 600 volts. So those are your kind of your working limitations on your ESS system. And so this all rolls back to listing 9540. What is the system? What is routine maintenance? All those kinds of things. What's accessible? And so, I would say just be mindful of that. And this is, when you get into a 2017 system where you're taking mixing and matching components, then you have to be very, very careful of this. If you're working under, a 9540 complete system, it's probably going to be a little easier to, not necessarily get away from, but being able to exceed that 100 volt limitation because of the system nature of those complete incorporation system, that is.
Mm-hmm. All right. So you kind of touched on this at the beginning, but can you discuss a little bit about adding or retrofitting a storage system, and specifically adding an ESS system or energy storage system to an existing small and or mid-size grid-tied PV residential and commercial slower? This is a very specific question. So this came in from Matt Serum. So do you have some comments basically on adding a storage system to an existing grid-tied PV system?
Yeah,
so what codes may apply? Yeah, go ahead.
Yeah, I can
Do you
start
want me to put that diagram back up or no?
Sure. I mean, we could. I don't know if it. Either way. Okay. But yeah, so we've actually been seeing this a fair amount, especially in our location, as a lot of people in California on their PSPS, their public safety power shutdown, not requirements, but the utilities coming through and in high wind, high fire events, shutting down the utility. Similar things are happening here up in Oregon. We have resiliency issues. And so it's a question that's coming up quite a bit. And it's an interesting one because you will be somewhat, having to shoehorn in a storage solution into an existing PV solution. And so a big part of, what you have to do is look at the system as a whole and just kind of trying to figure out all of the various components that are already in there and involved. One of the hardest parts, and I think Justine will have more to speak to this because she has some real great direct experience on doing a quite complex system, but looking if there's, we're talking about it in this question is very specific about, mid-sized commercial or something. There may already be a generator there. If having backup was an issue for whatever the site was to begin with, they may have a generator there. And so now you're having to interact potentially with a generator. So it's the control scheme that, quite honestly, I think is one of the biggest headaches on how to make it so that the ESS system is, communicating with the solar, which in of itself is probably not the hardest thing in the world, depending on inverters and age of the system. But now you throw in an existing generator, that's going to be quite complex. Control systems there. So making sure that all of the power production systems are playing nice is, probably the hardest part. And so I think the question also included was there codes that apply, that kind of stuff, and all the ones that we've already touched on would definitely apply. And then the other thing to step back and think about or look at is, are there emergency panels, for example, true emergency panels on site where there are legally required standby systems, egress lighting, things like, just different things that are truly considered emergency and need to be there. And then all of a sudden that just throws another layer of complexity into the mix. And so my kind of big takeaway from the project that we were working on is, get the AHJ involved early. Quite honestly, they're probably not going to know until you point out all these things, and it's going to just kind of somewhat open up a can of worms, but it's better in the beginning than in the end. So I don't know, Justine, do you have more from your lessons learned on your project?
No, just expanding on that a little bit. Sometimes you run into situations, especially with generators, and like you were saying, so you have an emergency panel that has to then all the parts and pieces that are going to be controlling the emergency panel. Now you're looking at Article 700. Well, your energy storage system may not be listed as an emergency rated automatic transfer switch. It's not going to be. And so, or at least that's been our experience. And so hopefully in future code cycles, they will make it a lot easier to play with these emergency panels, because, guess what? We're actually adding resiliency to these systems. We are doing good things. We're not just having to burn, fuel in a generator to extend our power, our backup panels capabilities during an outage. We're adding solar, we're adding batteries. These are good things for the ultimate goal of resiliency. And so we need to, hopefully there's this momentum in the codes to push through basically opening up the doors to energy storage systems to be able to play in these code sections that they need to if they're going to be powering up an emergency panel or something like that. And ultimately with our system, we had to redesign. We actually had to go back and redesign the system due to that particular article and the generator we were dealing with, the equipment we were dealing with, and it's reducing the functionality of what we're able to do there. It didn't kill the job, which is great, but we're going to be burning more fuel as a result of that particular code requirement. That it just doesn't have an avenue for an energy storage system to play in that particular setting, according to that AHJ. Maybe you can talk your HJ into some of these, getting by with some of these, but the bottom line is we actually do want to make sure this energy storage system works the way it's supposed to, and we don't want to take a perfectly capable generator out of the system, out of the situation, and put an energy storage system that hasn't been tested exactly. I mean, all this stuff's going to have to work ultimately to make sure we have the emergency power when we need it. But certainly there's avenues for that. I mean, generators are generators. They break down too, and they have their issues. So we should be able to play on the same playing field, but there's some, work in our industry that has to be done in the meantime.
Mm-hmm. All right, so going back to this diagram, one of the questions that we got in live from Sean Walters, hi, thanks for joining us today, was asking how would the NEC diagram change if we're talking about a DC coupled energy storage system? So earlier we were talking about specifically AC coupled and how all the different codes break down on that. So he was asking, how does this change for DC coupled? And I have that diagram. Let me see if I can share it. And we can kind of put these side by side.
I should have built one out. I might not be able to do it on the fly because I'm going to forget something. But if you pull it up big, oh, I got to make my screen bigger so I can see.
Yeah, let me see if I can.
And like I said, the reason we did this was just because the majority of the systems are going to be AC coupled these days, but certainly we can do the same thing for a DC coupled system. I mean, it's not, you're still going to have your energy storage system and your energy storage disconnect and your multi-mode inverter under Article 706. And
so I guess that does look better here. Can you guys see that okay if I do it side by side? Okay, so looking at this, basically this top part is all the same up to here, right?
Yeah, although it gets a little tricky. You're going to have more overlap. Because 690 really is going to stop, you know, when you get to your output circuits, you know, actually, Ryan, you're pretty good at this.
I was going to say your PV system disconnect is really going to be where
where
this is going to stop. And so your PV system, you're going to say your PV system disconnect, in this case on the DC coupled, is going to be on the DC side. And so it's the output. We're not showing, you know, charge controllers and stuff like that, but truly your PV system ends at that disconnect, because if you look at
right here,
because if you look at the rest of the system, and this all gets back into definitions and talking about all of the components needed to convert solar energy to electrical energy. And so in reality, because it's DC coupled, there's going to be some points. So this is, you know, it's a great, it's not meant to be used for a wiring diagram by any means.
Yeah, it's a starting point.
But that would be the biggest thing to answer the question. How would it change? It's really where that PV system disconnect, you know, is, and how it relates to the rest of the system. And so we will have some overlap, like we showed in the other image as well. But that would be the short
and
answer.
if you're going for 706, you're going to have to go up and include that multi-mode inverter there.
Yep.
But not necessarily the standalone load panel, you know, because that's going to be 70. Well, maybe one of those circuits. See, this is where it's kind of hard. Like you actually have to drill down in the code and be like, okay, which circuit are they talking about? Because there's several that talk about the multi-mode input and output circuits. It's like 710 and 705 and 706. You might be triple stacked with codes on your multi-mode inverter circuits, depending on what's happening there. And then
so 706 would probably cover these and maybe some of that.
We'll just say chapters 1 through 9 and annex A through D. Well,
706, not so much the standalone panel. No, I would scoot that over. That's going to be 710, sorry. So you could make another block going over the standalone system loads and the multi-mode inverter, and that's your 710.
So this and that is 710?
But not on the up, not like that corner piece. See, this is where it gets tricky. Yep.
There.
It's okay if you could push it all the way down to the bottom arrow instead of that top arrow. You know what I'm saying? Because that inverter output circuit that's going to the interactive system, that's going to be 705.
Right. So, and so yeah, as you all can see, I mean, this is gets super difficult super quick, even with a simple question like how would it just a DC couple look different. And so this is the exact kind of stuff that, you know, Justine specifically is wanting to, we'll be getting into on, you know, on the workshops that we're doing and things like that. So those are great questions, and you can see how quickly it can get very, very difficult to answer the questions.
Yeah, definitely. And that's a good point. We're almost to the end of the hour, and I just want to say thank you again to everyone who participated. And obviously there is so much additional information to dig into here. So if you are interested in learning more, definitely reach out to us about our workshops that are going to be starting in 2021 that Justine will be leading. And then also our next AMA series is going to happen in the beginning of next month. And we're going to be talking with RETC and specifically going over qualification testing and risk mitigation, and diving into that particular topic. That's on, I think, the second week of December, or is it December 8th? It's on our website. Sign up if you haven't already. You're probably going to get an email anyways from us since you attended this one. So check your email inbox for the next one. And yeah, reach out to us if you have any other questions. I'm probably going to touch on one additional question in here right now, but I wanted to let you guys know of how to reach out to us further. Add us on LinkedIn. We love hearing from you. And if you are interested in getting more questions answered, we have a little form that you can actually submit questions ahead of time. So for AMA sessions, keep that in mind. You can email us or submit your questions ahead of time. So thanks everyone, and we'll send you the recording. So this last question that came in is actually from one of our own, from Rye Heller. So he asked, if batteries have touch-safe terminals where battery cable is plugged into them, the battery system can exceed 100 volts. The same would need to apply when connecting the batteries to the multi-mode. Would the same need to apply when connecting the batteries to the multi-mode inverter?
So that's an interesting question. And the only thing that code talks about in the exception is having the exception when the live parts are not accessible during routine maintenance. And so I guess in my mind, installation is not maintenance, that those are two different things. And so in my mind, as long as you have your touch safe, as long as your components are not, they're isolated during maintenance, that would keep them meeting that exception, not necessarily having to be in installation. Justine, you may have a 180 degree view from me on that one. I don't know.
I wasn't listening. I was looking at these other questions.
I'm sorry, I wasn't listening.
But yeah, sure, Ryan, whatever you say. I'm saying, I think the whole point is not let people, that's a voltage we don't want to expose people to. It's really handy to have 48 volt systems because then we can fly under that voltage limit. If we get into that, you're going to be duking it out with your AHJ on what's considered accessible during routine maintenance. If you have to look at your documentation on what you have to touch, I mean, maybe they're maintenance free batteries, but do you ever seriously never have to touch them? Maybe. So that's going to, I don't think there's a clear cut answer in my mind.
Yeah.
Great. Are there any other, skimming through some of the stuff, are there any other ones you want to touch on?
Yeah, you know, since this will be a good one because this one had me scratching my head too, from Martin. When I first read the 2020 NEC, there's an article 70513, it's brand new for power control systems. And I was freaking out because I thought, I'm like, oh my gosh. One of the first things it says is a power control system must be listed. And there's just not a list of power control systems out there. But the whole point is, so I dug into this, I talked to some folks in the industry, in the code making panels on, okay, what's the purpose of this code section that's new? And what does it mean for our systems? And basically what I got out of that discussion is that if you're going to use those power control systems of an energy storage system to limit your current on your bus bars or conductors, then it must be listed. And so that made a lot more sense to me, because it was a little bit scary to think like, oh my gosh, am I gonna not, be able to pass inspection because our power control system, which we're creating basically with these larger systems because they're so custom, how is that gonna be listed? And the whole point was they're looking for, in the future, we know our devices can control and limit the current on this bus bars and conductors. And so there should be an avenue in the code section that allows for a different interconnection scheme if you're going to do that. But if you are going to do that, that device has to be listed. And so that's a little quick nugget on 70513.
That's good to know. And that was specifically in 2020, you said? Because I'm looking at the 2017.
2020.
Yeah.
2020. Okay. Yeah. In 2017, there's just a dot where it was pulled out. All right. Well, thank you everyone for attending and participating in this discussion with us. We really appreciate it. And we will be sending out the recording for this via email, posting it on YouTube. If you have any other questions, feel free to email us, technical@mayfield.energy, or our individual email addresses, which are up on the screen now. So thanks everyone, and enjoy the rest of your Tuesday.
Great, thanks.
Thank you.
Yeah.
They all gone?